Okay, I'm going to help you with your 6.4 homework, which relates to inverses. Sorry, in number 17 now. Let me start with number 17. This is on page 443. On number 17, I'm sorry, number 7. Start with number 7. On number 7, you're asked to basically derive the inverse for this particular function right here. Y equals 12x plus 7. The easiest way to do this, if you're asked to derive an inverse, is you swap the x's and the y's. So let's rewrite y equals 12x plus 7 as x equals 12y plus 7. Notice where we had y, we have x. Where we had x, we have y. Now you can't leave it this way. You have to use algebra to now solve this in terms of y equals. So we'll do minus 7 on both sides, and we'll get x minus 7 equals 12y. And then we'll divide both sides by 12. And so y equals x minus 7 over 12. That is the inverse. The inverse of y equals 12x plus 7 is y equals x minus 7 over 12. This is a fairly typical problem. So on the quiz, I'm going to ask you to do something like this and just swap your x's and y's and solve. In number 20, let's see here, let's do number 15. Okay, number 15, the instruction is different. In number 15, you're given f of x equals x plus 4 and g of x equals x minus 4. And you're asked to verify whether these are inverses of each other. Okay, now there's two ways to do that. One way to do that would be to just pick one of these, we'll say this one, and do what we did in number 7, swap the x's and the y's. We can rewrite f of x equals x plus 4 as y equals x plus 4. We can swap the x's and the y's, just like we did before, and then we can solve it in terms of y equals, and we get y equals x minus 4. And sure enough, this and this match. So that's one way to prove that this and this are inverses of each other. The other way to do it is to use composite functions. And remember, two functions are inverses of each other if these two conditions hold true, that f of g of x equals x and g of f of x equals x. Both have to be true for you to declare functions as inverses. Let's do f of g of x first. Our outer function is f, so we're starting with f. And we're going to substitute g of x in it every time we encounter an x in f of x. So f of x being x plus 4, okay, now we're going to do f of g of x. Well, we encounter an x, so instead of writing x, we write x minus 4. Then we continue on. And x minus 4 plus 4 is in fact x. So f of g of x does equal x. Now let's do g of f of x. We'll start with g of x. Remember, g of x equals x minus 4. Everywhere we see an x, we're going to substitute an f of x. So we start off and we substitute in f of x for this x. And once again, we get x. So f of g of x did produce an x. G of f of x did produce x. And because both produced x, both composites produced x, we can say yes, these two functions are inverses. On the quiz, I'm going to ask you to do it this way, not this way. You can check your answers this way, but I'm going to ask you to show me the composites, that these two hold true or not, and answer the question whether or not the functions are inverses. So be prepared for that. Lastly, I'll do number 31. Number 31 relates to the horizontal line test. In the horizontal line test, remember, if we have a function that looks like this, and we run a horizontal line through it, if it intersects the graph in more than one point, which it does here, we intersect it here and here, then this function, whatever it is, parabola, does not in fact have an inverse. So in number 31, they're asking you if f of x equals 1/4 x squared, they're asking you, does that function have an inverse? Well, let's graph it. So we'll come up with our grid here. We'll put x is 0. When x is 0, y is 0. Put in a 2 here. When x is 2, 2 squared is 4. 4 divided by 4 is 1. And then I'll go ahead and put negative 2 in. Negative 2 squared is also 4. 4 times a fourth is 1. So those are some points. We'll go ahead and plot those points. 0, 0, 2, 1, negative 2, 1, and this is our graph. And so the question is being asked, does this function have an inverse? Well, you would say it does not, because the horizontal line intersects at 2 points. So the answer to number 31 is no inverse. Okay, so those are 3 types of problems for section 6.4. Good luck.